So hello everyone, my name is Jakub Kulich and I'm from Poland, like Peter, from First Talk. Today I'm gonna talk about Kubernetes. Do you know Kubernetes? I hope that someone who doesn't know Kubernetes will take something from this talk. So what is Kubernetes? Kubernetes is open source tool that is used for orchestrating containers in cluster. It can deploy containers on nodes. It can be used for scaling these containers, and it provides service discovery, offers health checking of the containers, and some simple logging. Kubernetes is a tool that is designed by Google engineers, and it's based on their experience with deploying applications from like 10 years. What are some pros and cons of Kubernetes? I think it's major application for running applications in the cluster. It has a lot of features in comparison with other orchestrators like Docker Swarm. There's big support between cloud providers like Google Cloud or Microsoft Azure. In AWS, it's not so good. One big disadvantage of Kubernetes is that it has very steep learning curve when you want to deploy something in Kubernetes. It takes really long time. You must read a lot of documentation, but it's worth it. How Kubernetes works? Kubernetes works in that way that you describe your desired state of the application, how application would look like, which containers should be run, which volumes should be mounted into the containers, and everything else. And Kubernetes will try to make your dreams come true. Kubernetes has architecture that looks something like this. Each cluster should be with at least 2 nodes. One of the nodes is always Kubernetes master that is responsible for scheduling containers in the cluster across the nodes, and there are other nodes that are running all these pods and containers and everything. I will talk now about some basic entities that are used in Kubernetes. So first entity is deployment. It's the most used entity in all Kubernetes. It describes how application should look like. It describes usually one application in the cluster, like one microservice. How many of replicas should be run in the cluster. Deployment has always a pod template which talks about containers that should be run in the cluster, volumes that should be mounted into these containers, which environment variables should be exported into the containers, and some other stuff that Docker supports, like resource constraints for CPU and memory. It also has some stuff like health checking. So you can say that there is an endpoint in your application that is named health, and Kubernetes can check this endpoint to make sure that your application is alive. Another important entity is service. Service talks about which ports is your application using, which application should be accessible from inside of the cluster, which should be accessible from outside of the cluster, and it's used by Kubernetes to make service discovery. Sorry. Another important entities are config maps and secrets. They are very similar. Config maps are used for storing configurations. You can upload your configuration to Kubernetes and then use it in the container. It can be mounted, or another way is to use contents of the config as environment variables in your container. Secrets are used for storing sensitive data like keys, API keys, tokens, passwords, and everything like this. Next resource is ingress. It's a special resource. Every Kubernetes has some gateway to Kubernetes that is called ingress controller. It's usually engines configured like reverse proxy, and usually it's running with Golang that is watching Kubernetes for these ingress resources that are mentioned here. And when some of the ingress resource is changed, it generates a configuration for engines and reloads engines. Now I have some short demo. So I have a simple application that is composed from two microservices. One is named Banana and it returns banana and model or maker of this banana. Another microservice is Apple service, and again it returns some Apple. We have some Docker file here. Docker file is used to build one image that contains both binaries for Apple service and also for Banana service. You can imagine that we have some sort of continuous integration, and we build Docker image, pushed it into Docker registry, and now we need to deploy this to Kubernetes cluster. Here is Kubernetes deployment. This is a label of this deployment. It's named Apple photo. Then there's namespace in the Kubernetes where application should be run. The namespaces are entities that are used to divide Kubernetes cluster into logical units that are and applications running in these namespaces aren't visible in another namespaces. We have number of replicas here. It's one. So when we deploy this application, it will run one pod, and this pod will contain one container that is called Apple, and it's with this image that we built and pushed. I pre-built this image and pushed it before Golang Meetup because it takes a long time and it's not good internet for pushing images to Docker registry here. Then when application is deployed, it runs binary named Apple, and the application is using port 80 for HTTP communication. Next entity that we have here is Kubernetes service. Again, it talks about port 80 that is used. We can also configure this application to be available outside of the Kubernetes cluster by adding option here type node port. default its cluster IP, and it makes application available only inside from the cluster. Banana deployment is very similar. It's same, and service is same too. Now we can deploy this application Kubernetes cluster. I can show you here that it's empty. We have some namespace here, and we have nothing running here. We can deploy just whole folder with configs. Shows that these resources were created on Kubernetes. And when we refresh this, we see that 2 applications are running, and each has 1 pod. We can easily scale applications by setting number of replicas here. So we just click that we want 3 pods, and when we look here, then 3 pods named Banana were started. When we try this, application is one thing I didn't show is ingress resource. It routes request, HTTP request into cluster. Everything that comes with this domain and comes to this route is routed to application Apple and port 80, and everything that is with subdomain with domain this and this route will be routed to Banana service. We can see here that Banana is deployed, and we can also see that Apple is deployed too. Another thing I want to show you is rolling update that is possible with Kubernetes. It's type of the update where pods are replaced by Kubernetes one by one, and it makes possible update of the application with 0 downtime. So we can take application Apple. We can change model of Apple from Yellow Gold to Golden Delicious, because Golden Delicious are better apples. Now again, we must build container, push it into Docker registry. Usually it's done by continuous integration system. Another thing we should change is now name the image that we want to deploy. And now when we deploy these configs, we can see that everything was again configured. And we will see that application was deployed again with version 2. And when we look here, model is Golden Delicious. I think that's all. Do you have any questions?
I'd like to ask, what is the main point to choose this over the Docker Swarm? Like the main advantage of this?
I think that Kubernetes has a lot of more features that are not in Docker Swarm and are usually needed in production. I think one of these things that are good are config maps and secrets. This is something that Docker Swarm doesn't know. Another thing that is missing in Docker Swarm is something like ingress, that gateway that is routing requests in between microservices. And there are a lot of more stuff that is missing in Docker Swarm.
And it's open source, Kubernetes.
Yeah. Yeah.
So if you have something that is missing, you can implement it yourself. If you really need it, it's good. You don't have to pay.
Please, I didn't understand.
What are you using to test the application locally on Kubernetes? Or are you always deploying it onto a remote cluster?
Our applications are usually tested in continuous integration tool, and where everything is tested, Docker images are built and are updated in Kubernetes cluster.
So you are not running Kubernetes on your local machine?
No. Is there? I said that usually Kubernetes clusters should have more than 2 nodes, or 2 and more nodes. There is one exception, and there is an official tool called Minikube that runs some lightweight Kubernetes in your computer. Someone uses it for local development, but we are not doing it this way. More questions?
Are you using for your deployments your own Kubernetes cluster on your hardware, or are you using some cloud provider for the Kubernetes cluster?
We are using cloud provider. Okay, thank you.